All right, everyone, we are looking at solving equations, but this time we are setting up our equations to do our solving. So we kind of saw this yesterday. We're setting up our expressions, but since we knew the total amount, that's why we had an equal sign there, which is why we're able to solve. Expressions, no equal sign, just a statement. Equations has an equal sign, and we can end up solving here. So let's see here. We got Yoshiro here, who's got a new puppy. All right, she decides to create an enclosure for her puppy in the backyard. The enclosure is in the shape of a hexagon, all right, with one pair of opposite sides running the same distance along the length of two parallel flower beds. Okay, so here we go. Flowers. All right. All right, fine. Go ahead and laugh there. All right, how about more of a tulip over here? There we go. There we go. All right. All right. So we've got our hexagon. It's running along the two sides there. So the two boundaries at the end of the flower beds are 10 and 12 inches respectively. And at the other end, the two boundaries are 15 and 20. Okay, respectively. If the perimeter of the enclosure is 137 feet, what is the length of each side that runs along the flower bed? Okay, so what they've said here is that the opposite sides ones are the same distance. So we know that these two are the same distance. But what we do know that is the hexagon, all right, one of them is going to be 10 and another one's going to be 12. Now, we don't know that these are the same size. In fact, I'm sorry, let me rephrase that. We know that these aren't the same size because one is 10 and one is 12. We're going to complete our hexagon, something like this, all right, and we know we got ourselves a 15 and we've got a 20. Now, again, obviously not drawn to scale, but they don't need to be. All right, so let's see what we got going on here. We know the perimeter is 137 feet. Okay, so perimeter is when we add up all the sides. So we don't know how long this side is, so I'm going to call it X. But what we do know is that this side was the exact same distance. So that means this is going to be an X as well. Well, now I can set up everything because perimeter means to add everything up. So I'm going to take my 10, add on my 12. All right, I'm going to group my like terms. Add on my 20, add on my 15, and then I can add on my two X's. So we add up all the sides. 1, 2, 3, 4, 5, 6, 6 sides, hexagon. All right, I know I'm supposed to get 137. Ooh. All right, so now we can go ahead and start solving. Let's combine like terms here. So if we do our addition, 12, 32, 42, 47 when we add, and x plus x is 2x. All right, let's solve our equation now. Subtract 47 from both sides. 2x equals, in this case it's going to be 90. Divide both sides by 2. So when we do that, we get x equals 45. All right, so when they ask here, what is the length of each side that runs along the flower bed? There it is. Each side is going to be 45 feet. So the key thing here is picture. All right, labeling the information and then using that to set up our particular equation. All right, so let's see what we got going here with Jenny here and at swim practice. All right, she's on the local swim team for the summer and has swim practice 4 days per week. The schedule is the same each day. The team swims in the morning and then again for 2 hours in the evening. If she swims 12 hours per week, all right, how long does she swim each morning? Well, all right, so again, little pieces. Don't expect just to jump right to it. So notice I read the first question once, and I always kind of go back. Okay, so she's on the swim team. They practice 4 days a week. All right, so I know we're practicing 4 days a week. So there's 1 day, there's 2 days, there's 3 days, there's 4 days. I'm going to go a little more visual here for this one. Schedule is the same each day. All right, this team swims in the morning and then again for 2 hours in the evening. All right, so I know that they're going to have a morning swim and then 2 hours, a morning swim and then 2 hours, a morning swim then 2 hours, a morning swim and then 2 hours. The thing about it is they did tell me that the schedule is the same each day. I know it's a total of 12 hours per week, so I know I'm going to add all those things up. All right, but I don't know how much she swims in the morning. So I'm just going to call those pieces M. So when we add all of this up, all right, I've got 4M, all right, and then 2, 4, 6, 8, and then our 8, and that gives us the total to our 12. Some of you might go, wait a second. In the morning she swims this much, add on 2, but then does that a total of 4 times. Can't I just do this? You can, and look what happens. 4M and 8, and there it is. So again, lots of ways, just don't fall in love with one particular method. So let's subtract 8 from both sides. 4m equals 4. We'll divide by 4, and m equals 1. All right, 1 hour. All right. Again, we want to make sure we can do the setup. We don't want to just fall in love with guess and check. You might be able to guess and check some of these answers, but when they don't come out neat and clean, it's going to get rather frustrating. Okay, so here we're just solving our equations. So what I would suggest to do is go ahead and hit the pause button, all right? And if you don't, police will be showing up at your door to make sure that you take care of that. So go and solve 1 and 2. When you're done solving 1 and 2, then go ahead and hit the resume button. All right, so we're back here. Did you subtract 4 from both sides? Did you say 5x equals 15? Did you divide both sides by 5? So did you say x equals 3? All right. For here, did you subtract 14 from both sides? So did you say 15x equals 15? Did you divide by 15 on both sides? Did you say x equals 1? So this is just kind of, again, nice little kind of review, like a little intermission, like, hey, remember these? All right. Let's see, we got question 3. We got Claire's mom found a very good price on a large computer monitor. She paid $325 for a monitor that was only $65 more than half the original price. What was the original? Okay. All right. So this is where it was, everything seemed to be going real nice, and then all of a sudden they got a lot of word going on here. So again, break things down. She paid $325 for a monitor. Okay, that was only $65 more than half of the original price. Okay, so if I take half the original price, it was only $65 more than half the original. So I know she paid $325. Okay, so again, it was 65 more than, that's why it's your plus, and then half the original. So I don't know what the original price was. I'm going to call it x. So we'll subtract our 65 from both sides. So we got half of x equals, and then we do a little subtraction here. Now, here's the thing that we want to watch for. We're going to go back to one of our properties. What happens when you multiply a fraction by its reciprocal? All right, when you multiply the fraction by the reciprocal, you always get, you get 1. And that's known as what property? The multiplicative inverse. So because I'm multiplying by half, I'm going to actually multiply by 2 over 1. All right. Now, again, the whole reason why is these guys will knock each other out. I got x all by itself. So 220 times 2, 440. So it's originally $440. So again, when you have a fraction, all right, make sure that you go ahead and then you go ahead and you multiply, all right? Multiply by its reciprocal, and that'll always get rid of the fraction. Otherwise, you're going to divide by a half, and let's think about it. Dividing by a half is the same thing as multiplying by its reciprocal. Oh my goodness, it's the same thing that we just did. Yes. So again, dividing by a half is the same as multiplying by 2, because again, you multiply by the reciprocal. All right, we can skip 4. All right, we'll come across one of those guys later on there. Let's go ahead and hit 5. Oops, a little bit too far, but that is the last one. So let's see what we got here. All right, we got Ben here. All right, Ben's family left for a vacation after his dad came home from work on Friday. The entire trip was 600 miles. Dad was very tired after working a long day and decided to stop and spend the night in a hotel after 4 hours of driving. All right, the next morning, Dad drove the remainder of the trip. If the average speed of the car was 60 miles per hour, what was the remaining time left to drive on the second part of the trip? Okay, and this is, remember, distance is rate multiplied by time. So, all right, so let's see here. The entire trip was 600 miles. Okay, so we've got to get from here all the way to there. All right, so from here all the way to there is going to be 600 miles. All right, so he was very tired and decided to spend that after 4 hours of driving. Okay, so after 4 hours, he stopped. Now, the thing about it is they did tell me he was going 60 miles per hour. So if he's going 60 miles, all right, per hour, which means 60 miles. Ooh, looks like go there. 60 miles in the 1 hour, and we know he drove for 4 hours. The idea here is we know then he drove, times it by 4, we know he drove 240 miles. All right, so we know he drove 240 already. Now, so what's the remaining amount that's left? Well, we can do a little bit of a subtraction problem here. All right, so 600 minus 240, that's going to give me 360. So I know the remaining portion is 360. Now, the remaining portion is 360, and he was going 60 miles per hour. So I want to know 60 times something has to give me 360. Now, this is one of those cases where we really didn't set up an equation, all right? But we would like you to kind of look back as to how you could end up setting this particular equation. So first of all, to finish, we could divide both sides by 60. Microsoft's not responding for me. Let's pause for station identification. Oh, we're back. So we would divide both sides by 60. So let's finish this here. We do get 6. All right, so there it is, 6 more hours. So what's the remaining time left to drive? It is 6 hours. Now, part of it is equation-wise, what would this look like? Well, we know we've already gone to 240 plus, and then I don't know how much more we've got going on here, but I know it's a total of 600. I do know that 240 plus, and then, all right, 60, I don't know how many hours, has to give me 600. And then watch what happens here. Subtract both sides by 240. Oh my goodness, there it is. Divide by 60. Oh my goodness, there it is. So again, I've got really no problem with just solving it. But if the directions say we need to write an equation, that's kind of what we work on, is the ability to write an equation. Sometimes if you solve it and go back to write your equation, there's nothing wrong with that. The issue here is when you get some numbers that don't come out neat and clean, and you're just you're not really using an equation, that's when your frustration level is going to set in. So we do certainly want to work on that solving equation portion, and if we said write an equation, then that would be the equation we're after. All right, so that's it we got for you today. Again, you do want to make sure that you continue to pause, kind of rewind, kind of listen over again, because that's certainly something that's going to kind of help you out with that. Sing along, people.